This is 7.4 part 2, and we're going to look at objective number 3. So objective number 3 says determine the signs of the trig functions of an angle in a given quadrant. So if you remember, there are 4 quadrants, and I'm going to draw them for you right now. Okay, so quad 1 is here, quad 2 is here, quad 3 is here, and then finally quad 4 is here. And we have 0, 90 degrees, 180 degrees, 270 degrees, and finally 360. So when we talk about the unit circle, we talked about what quadrants are positive and which ones are negative. So in quadrant 1, both your x value and your y value are positive. So therefore, if we take tangent, which remember tangent is sine over cosine, it's also going to be positive. So basically all of the trig functions are positive in quadrant 1. In quadrant 2, my x is negative and my y is positive. So what does that mean? That means that cosine's negative and sine is positive in quadrant 2. Tangent's also negative because remember tangent is sine over cosine. And then the reciprocal functions are going to follow suit. So the reciprocal of cosine is secant, which is also negative. And the reciprocal function of sine is cosecant. So both sine and cosecant are positive in quadrant 2. In quadrant 3, both my x and my y values are negative. So that means cosine is negative and so is sine. But when we get tangent, we get sine over cosine, or a negative over a negative, which makes it positive. So tangent and its reciprocal function, cotangent, are positive in quadrant 3. And finally in quadrant 4, my x value is positive, but my y value is negative. So that means cosine's positive and sine is negative. So cosine and the reciprocal function secant are positive in quadrant 4. So everybody else in the quadrants, if it doesn't say, for instance, quadrant 2, sine and cosine are positive, all the other functions are negative. In quadrant 3, tangent and cotangent are positive, all the other functions are negative in quadrant 3. And in quadrant 4, cosine and secant are positive, the rest of the functions are negative in quadrant 4. So there's a little mnemonic device to help you remember this. All students take calculus. And if you remember that, the first letter of that little statement, all students take calculus, stands for what's positive where. So in quadrant 1, all of the functions are positive. In quadrant 2, students, the S stands for sine. And then we would also bring over its reciprocal function. In quadrant 3, we have take, which stands for tangent, and cotangent. And in quadrant 4, we have calculus, so the C stands for cosine and secant. So all students take calc. A stands for all, S stands for sine, T stands for tangent, and C stands for cosine. And this wraps around the unit circle. So quad 1, quad 2, quad 3, quad 4. So you can even draw it out like this. All students take calc. Okay. So this is helpful when you're doing a unit circle. It's also helpful when you're trying to figure out what's positive where. So here's an example of a problem which would require you to know what's positive where. So it says if sine theta, and you're going to need to draw in the theta there, is greater than 0 and cosine theta is less than 0, name the quadrant in which the angle theta lies. Okay, so if I use a little mnemonic device, and by the way, you can use either the signs like plus plus, minus plus, minus minus, plus minus for the 4 quadrants, or If you want to use this, it's up to you. So if I use the mnemonic device, all students take calculus, I know that sine is positive. Let me write that out in a color that we can see. Sine is positive in quadrant 1 and quadrant 2. Furthermore, it goes over to say cosine is negative. So cosine, and once again, if we use this, all students take calculus. Cosine is negative in anything that doesn't have an all or a c in it, right? So that's quadrants 2 and 3. So the overlap here is quadrant 2. That's where sine is positive and cosine's negative. So the answer to this is quadrant 2. The other method you could have used is, like I said, you could use plus plus, minus plus, minus minus, plus minus. If you use this method, remember you have cosine, sine. So you're looking for where cosine is negative and sine is positive. So you find the quadrant that has that matching up, and once again it's showing it's quadrant 2. So you have 2 different methods you can choose. It's up to you. All right, objective number 4. Find the reference angle of an angle. So a reference angle is always a quadrant 1 angle. Okay, so that's what it's called. So the definition says, let theta denote an angle that lies in a quadrant. The acute angle formed by the terminal side of theta and the x-axis is called the reference angle. Remember, acute means less than 90 degrees. So that's why I said it has to be a quadrant 1 angle. Also, the x-axis is like a magnet. You're either going to be subtracting from 180 or taking the angle minus 180, or you're going to take 360 minus the angle. So let's check this out and see how this makes sense. So the first example A, the terminal side is in quadrant 2. So if I create a triangle out of this, I would create a triangle with the 180 degree mark. So in quad 2, I have to take 180 minus my angle, and that'll give me my reference angle. Okay, so what are we doing? We're referring the angle back to quadrant 1. That's why it's called a reference angle. So let's check out quadrant 3. So once again, my terminal side is in quadrant 3. I'm going to make a triangle with the x-axis, where the x-axis is the base. So this time around, I'm going to take my angle minus 180 degrees to get my reference angle. Okay, the next example. Now I'm in quad 4. So if in quad 4, once again, to create my triangle, I can create this with the x-axis, where the x-axis is the base. So therefore, to find the reference angle, I have to take 360 degrees minus my angle. And finally, if you have a negative angle, like in example D, then I look at it and I say, okay, whatever that angle is, and obviously we're in quad 1. So what I might want to do here is take 360 plus your negative angle, okay? So plus the negative angle. And when you do that, what's going to happen is you're going to get 360 minus the angle. Whoops, I don't know what happened there with that pen. And that'll give you your reference angle, okay? So that's how we do these. And once again, remember, you're creating a triangle with the x-axis as the base of the triangle. So let's look at this next example. It says find the reference angle of 220 degrees. The first thing I would do is figure out where you are. So if you draw it out, you will see you have 0 degrees here, 90 degrees here, 180 degrees here, 270, and then up to 360 again. So 220 is going to be an angle in quadrant 3. So once again, if you create a triangle with this, you're always creating that triangle with the base of it being the x-axis. So since I'm in quad 3, and since my triangle looks like that, I'm going to take my angle minus 180 degrees. So my angle is 220 degrees less 180. So when I do that, I get 40 degrees. And that is my reference angle. Once again, a reference angle has to be a quadrant 1 angle. So 220 degrees refers back to the 40 degree angle. Okay, so let's look at this next example. Find the reference angle of the angle. So now we have 12 pi over 5. If you don't want to work in radians, you could change this to the degrees, or your other option is to make sure that all the key points, 0, 90 degrees, 180, 270, so on, has the same denominator of whatever you're doing. So I can show you both ways. Let's do radians first. So if you leave them in radians, to figure out where I'm at, I'm going to have to convert everything over so that the denominator is a common denominator. And so normally we'd have 0, pi over 2 for 90 degrees, pi for 180, 3 pi over 2, and then 2 pi. So if I'm going to change these so they have a denominator of 5, pi is going to be 5 pi over 5. And 2 pi is going to be 10 pi over 5. So I can kind of get an idea that more than likely I'm in quadrant 1. So basically what this angle has done is it's gone all the way around and then ended up here. So we have this situation. Okay, so the terminal side here is 12 pi over 5. So once again, if you've wrapped around or if you have a negative angle, to figure out what the reference angle is, I'm going to take 2 pi minus the angle because I'm in quadrant 1. So 2 pi once again is 10, and I said that backwards, so let me fix that. It's actually going to be the angle minus 2 pi. Sorry about that. So we have 12 pi over 5, and remember 2 pi is 10 pi over 5. So we get 2 pi over 5 as my answer, and that is a quadrant 1 angle. So that's the first one. So let's see what happens when we convert to degrees. So we can do it either way. Once again, if you're happy with dealing with the denominators in the radians, then leave it like that. But you can convert this to degrees. So 12 pi over 5, if we convert it to degrees, remember we have to take 180 over pi. And then we have to reduce this down. So let's reduce. The pi's will go away. So let's do that. And 5 goes into 18 3 times. And 5 goes into 36 times. So now we have 12 times 36. So let's figure out what that is. Okay. I got 432 degrees. So if I were going to draw that out, I have 0 degrees, 90 degrees, 180, 270, and then back again to 360. Now 360 plus 90, remember, is 450. Okay, so I know I'm in quadrant 1 because my angle is 432 degrees. So if I draw that out, I know I have to go all the way around and then back up again. So I do the same thing that I did with part A. I'm going to have to take my angle minus 360 degrees. So my angle is 432 minus 360. So let's figure out what that is. I got 72 degrees. So my answer is going to be 72 degrees. In degrees instead of radians. So once again, you have two choices. You can either, leave it in radians and just make sure you convert things over so that they have the same denominator, or you can convert it to degrees right away and then deal with it. Okay, so here's another example. Find the reference angle of negative 11 pi over 6. I'm going to leave it in radians. Like I said, if you want, you can convert it to degrees, but for this example, I'm just going to do radians. Okay, so we have 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So I notice my denominator is a 6. Negative 2 pi is going to be negative 12 pi over 6. And negative pi is going to be negative 6 pi over 6. So negative 11 pi over 6 I know is in quadrant number 1. Okay, so if I draw this angle out, remember I'm going clockwise and my angle looks like this. Okay, so what I want to do now, instead of taking 360, we're going to take 2 pi. Okay, and then we're going to add the negative angle to that. Okay, so 2 pi, remember, is going to be 12 pi over 6, right? And then we're going to add the negative angle, which is negative 11 pi over 6. Okay, so I basically have 12 pi over 6 minus 11 pi over 6, which is pi over 6. So that is my reference angle. Okay? All right. So now let's take this up a notch into objective number 5. Use a reference angle to find the exact values of the trig functions. Now you need to do two things. One, you have to figure out the reference angle, and then 2, you have to figure out if your reference angle is going to be positive or negative. To figure that out, it depends on what quadrant you're in, and also it depends on what function we're looking at. So reference angles, sine can be positive or negative. Cosine can be positive or negative. Tangent can be positive or negative, and same with the reciprocal functions. Okay, so once again, for this portion, you might want to use all students take calculus. Once again, that tells you the positive angles or the positive function and what quadrant they lie. Or you could also use the sign. So plus plus, minus plus, minus minus, and finally plus minus. So either or will get you where you need to go. Okay? So let's go ahead and look at this. Use the reference angle to find the exact value of the following expression. Do not use a calculator. Okay, so the first thing you want to do is draw where 150 is. We're in degrees, so I'm going to have 0 degrees, 90, 180, 270, 360. If I draw this out, I know that this is in quadrant number 2. So there's my angle. Okay. And now you need to figure out, is sine positive or negative in this quadrant? Okay. So once again, you can use all students take calculus. So in quadrant 2, because remember we're in quadrant 2, in quadrant 2 sine is positive. Okay, all right. So your next step is to find the reference angle. Okay, since I'm in quad 2, and I'm looking at that terminal side of the angle, I can create the triangle with the x-axis. So what I need to do with that is I need to take 180 minus my angle. So I'm going to take 180 minus my angle, which is 150, to get 30 degrees. This is my reference angle. Okay? So now I have one last step to do. We got to evaluate it. So what I'm looking for is I'm going to take the information whether sine is positive or negative. So I'm going to leave it be positive because I'm in quad 2. And then I'm going to actually find what sine of 30 degrees is. Okay? So you can use your triangles. Hopefully you have this memorized by now, but if you don't, please take some time to do so. But sine of 30 degrees is 1/2. So because I'm in quadrant 2, it's positive, and my value is 1/2. So for these problems, you have to figure out if your answer is going to be positive or negative, and I determine that by which quadrant I am in and which function it is. And then you have to find the reference angle and then put the pieces together. By the way, you could have done this problem using the unit circle as well, because sine of 150 is one of those values on the unit circle. Okay, so I think this is the last objective. Yes, it is. So find the exact value of the trig functions of the angle, given information about the functions. Okay, so let's look at this and see what the heck they want us to do. You're going to have to draw it, then use SOHCAHTOA to figure out the rest, okay? So this is going to be a little bit harder than the last objective. Given that cosine theta is equal to -2/3 and that theta is a value in between pi over 2 and pi, find the exact value of the remaining 6 trig functions. So first, what quadrant are we in? Okay, so once again, if we write this out quickly, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. It tells me that my angle has to be between pi over 2 and pi, so therefore I'm in quad 2. Okay, so if you remember, all students take calculus. The only thing that's positive in quadrant 2 is sine. Okay, so I'm going to put a little note here that sine is going to be positive, and so is cosecant. If you want to, you can write down that the rest of the trig functions are negative. So that might be a good idea to do right off the bat. Okay? Second step will look familiar from what we did before. We know that cosine is equal to -2/3. Okay? So if I draw a triangle, and by the way, I'm going to go ahead and ignore the negative just for now. If I put theta here, remember cosine is adjacent over hypotenuse. So the adjacent side is going to be 2 and the hypotenuse is going to be 3. I got to find the missing side. So I'm going to use Pythagorean theorem. So that says that we have a squared plus b squared equals c squared. A is going to be the 2. B, I don't know what it is, so I'm going to leave it set as B, and then the hypotenuse is 3. So I get 4 plus b squared equals 9. B squared equals 5, so b equals square root of 5. Okay, so I'm going to go ahead and put that information in. I'm going to put this in purple so you know that that's what I just found. Okay, so now that I have that information, I'm going to go ahead and get the rest of the 6 trig functions. So let's do sine first. So remember, sine is opposite over hypotenuse. So sine theta is going to be opposite, which is square root of 5, over the hypotenuse, which is 3. Remember, it's positive because I am in quadrant 2. Cosecant, which is a reciprocal function of sine, is going to be 3 over radical 5. I have to rationalize this, so I multiply everything by radical 5, numerator and denominator, and I get 3 radical 5 over 5. It's also positive because I'm in quadrant 2. Cosine was given, so cosine theta is equal to -2/3. So therefore its reciprocal function, which is secant, is also going to be negative, and I flip that over to get 3/2. And finally, tangent. Tangent theta is equal to opposite over adjacent. So the opposite side is the square root of 5. The adjacent side is 2, and I can accept that answer. Now cotangent is a reciprocal function, and by the way, I forgot to put on the negative sign. So make sure I put the negative sign there because tangent is negative in quadrant 2. Cotangent, you flip it over to get negative 2 over square root of 5. And now we take and find the rationalization of this, which is negative 2 radical 5 over 5. Okay, so one last step, just check them because it's really easy to make a mistake on your signs. So cosine and secant are negative because I'm in quadrant 2. Tangent and cotangent are negative because I'm in quadrant 2. And sine and cosecant are positive because I'm in quadrant 2. So I just double check the signs right at the end to make sure I got everything. And that's how you do this. And that's the end of the video.